Hello, I'm Steve Lewis. Welcome to the second module of Applied Statistics for Healthcare Data Analysis. This course is funded by a grant from the United States Department of Labor and uses a curriculum developed by Carnegie Mellon University. Today we're going to be talking about data production. If you recall from the previous module, the curriculum lays out a four-phase model of statistical analysis. It starts with the extraction of data from a population of interest, subjects those data to exploratory analysis to create descriptive statistics, applies the principles of probability to those statistics, and then allows for inference about the population based on the probabilities associated with the statistics that we found in exploratory analysis. You also recall that the sequence of the first two steps was reversed, and we talked about some of the characteristics of exploratory analysis, partly by way of setting some context for what we would need in terms of the data produced to be able to do that analysis, to give us a flavor for what would be required of the data in order to perform analysis. Today, we're going to be picking up the thread of one very important consideration, and that was the fact that we have to allow for statistical analysis in the basic design of our study or our investigation. And when we talk about producing data, that idea very clearly comes home to roost. One of the important distinctions made in this module about data production is around the distinction between observational and empirical studies. The point is made very clearly that the analysis, both at the level of exploratory analysis and then the inferential analysis following that, is much more robust if the model of study used is experimental, where variables can be controlled and or manipulated, as opposed to observational, where the facts on the ground have to be taken as they present themselves, both in terms of what variables can be identified as potentially relevant and in terms of what data are available about those variables. A reality check here is the fact that, for the most part, you will, in reality, be dealing with observational as opposed to experimental study modules. The questions you will be asked to answer are around what happened, not around what would happen. The upside of that consideration is the fact that the more stake the organization or the sponsor of the research has in the outcome of the study, the more likely it is to be willing to undertake the investment and the time and the other commitments necessary to do an experimental as opposed to simply an observational design. But regardless of whether we are talking about an observational or an experimental model, a large part of the body of research you're going to be doing assumes that you are going to be taking a sample of data from your population. Now, as big data evolves, and as more and more data around healthcare becomes captured in the data sets associated with interoperable electronic health records, the claims and billing data, and all-payer or multi-payer claims databases being developed largely under the aegis of government agencies, and epidemiological data sets, that is not necessarily going to be as frequent a requirement as it has been in the past. Increasingly, it is possible to capture all of the data of a given sort about a population of interest, depending on how that population is defined. For example, if the population of interest is the subscriber population of a given health insurance carrier, the claims data and billing data of providers associated with that payer are going to be a universe for which a census of certain variables can be captured. But back in the world of reality, for the most part, you are going to be having to develop a sample of data from the population. There are two principles that come through primarily in discussing sampling. The first is the value of randomness. Randomness in sampling simply means the idea that any one event, any one case in the population has an equal chance of being included in the sample as any other case. The second point is that size matters. In general, the larger the sample is, the more representative it is of the population from which it's drawn. And I think that's probably intuitive. That does not imply necessarily that a sample has to be a given percentage or proportion of the population from which it's drawn. There are other drivers which determine the criteria for sample size relative to the degree of confidence you want to have in your findings and the nature of the research questions being investigated. But as a general proposition, a larger sample does enable inference that gets closer to an estimate of the corresponding values for the population. There will be discussion in this section of varying sampling methods with varying degrees of randomization and varying places where randomization can occur in the process of sampling. These differences have to do partly with practical questions of where the data may come from, but also of design assumptions around which variables may influence the values of another variable and have to be accommodated in the sampling. That may sound a little bit cryptic, but I think that the examples in the curriculum lay out those considerations pretty clearly. So at this point, I think we will stop for the moment, and I'll allow you to take a look at the materials on sampling and data collection. And then next time we are going to pick up the thread of probability. And this is where it really gets interesting. Thanks, and I look forward to seeing you then.